In this video, we are going to be classifying lines in both 2 dimensions and 3 dimensions. We'll start with a quick review in 2 dimensions. We can either have intersecting lines, where there's one point of intersection, they intersect there, and we get one specific unique solution, which is that coordinate point. They can be parallel, where they do not meet, there's going to be no solutions. Or they're coincident, which means it's a line that falls on top of itself, so there's an infinite number of solutions to that system of coincident lines. In 3 dimensions, we can have coplanar lines. So all of our lines are going to fall within the same plane. So they can either be intersecting again, parallel, or coincident. Same type of thing as in 2 dimensions because they lie on the same plane. So even if it's 3-dimensionally, they may not go in the z direction or the y direction, depending upon where they are. However, if they are non-coplanar, then they could be skew. They could intersect still. They could be skew if they're not parallel and not intersecting. If they're parallel, then we know that the angle between them is going to be 0. If they're intersecting, the angle between them is going to be theta, and we'll be able to find that. And if the lines are skew, there's still going to be an angle that one of them is going to make with the other if we just translate the one line onto the other to intersect it. The angle between the original lines is defined as the angle between the intersecting lines, which is that angle theta again. So we'll be able to find that intersecting angle even though they don't technically intersect, because think of skew lines as having, you can think of 2 lines here. Here's one line, and then I have a line that's coming out of the chalkboard into that point. Okay, so those would be skew lines in that 3-dimensional region. So we'll be able to look at 2 equations, figuring out that they are parallel, showing that feature. These lines that we're going to have are 3-dimensional. There's an x, there's a y, and there's a z. So if I start with line 1, so I have some point x, y, z. So I'm going to be taking my parametric equations and writing them in vector form. I have that initial point. For x it's -1, for y it's 1, for z it's 1, plus s is the multiplier on it, 2, -2, 4. And then for line 2, that's some x, y, z. And I have again that starting point, 1, 0, 3, plus t is its multiplier, times its direction vector, -1, 1, and -2. So if they're parallel, I should be able to take 2 directional vectors and multiply them by a constant. Multiply one of them by a constant. If that's true, then they are going to be parallel lines. So I'm going to take both of my direction vectors. I have 2, -2, and 4. That needs to equal some constant multiplier times my other one. I can take any of these 2 and start and go backwards and forwards. In this case, this k value has to be 2, -2. So that when I multiply them together, they're equal. So since this k value is -2, it is a true statement. Therefore, the lines are parallel. So this is kind of how you can show that feature. Next, I'm going to have 3 lines I'm going to work with. So we're going to be showing that line 2 and 3 intersect, and then if they intersect, we can find the angle between them using our cosine formula. So to begin with, I'm not using line 1, so I'll kind of get rid of that. We're going to do this one on the next page. So in order to show that these lines intersect, I have to solve for my t value, I have to solve for my u value, and then I have to check to make sure it's actually the exact same value. So to start, I'm going to set up my x values. X equals 1 minus t, and x also equals 1 plus 2u. So doing some substitution. And then let's just look at my y values as well. So y is t, and my other y value is -1 minus u. So I can set these two up, combine these two together using substitution, because I have it already solved for t. T equals -1 minus u. So putting this in place here, I get 1 minus the quantity -1 minus u equals 1 plus 2u. 1 plus 1 plus u equals 1 plus 2u. Subtract the u over, subtract the 1 over. 1 equals u. Now that I have what u equals, I'm going to plug 1 in for my u value. So t therefore equals -1 minus 1. So t equals -2. So I have my u value, I have my t value. Now what I can do is I can plug that back into my third equation and make sure that works as well. So my z's, 3 minus 2t equals 4 plus 3u. Substituting in -2 for t and 1 for u, I get 3 minus 2 times -2. That has to equal 4 plus 3 times 1. So 3 plus 4 equals 4 plus 3. 7 equals 7. It checks. Therefore, they intersect. You technically should check it back into all of them. I did end up using this equation to find my t value, so I should actually go back into this first one, make sure that it is a true statement, that t is -2 and that u is 1. The other thing that I could do is I could plug each of my values in, get my x, y, and z. So I can put in my t value of -2, I can put it in here, put it in here, put it in here, and then I can take that u value and plug it in here, and here, and here, and those two coordinate points are going to have to be exactly the same. That's going to show that they are intersecting. So they do intersect. So now I can find the angle in which they intersect at. So in order to do this, I'm going to list my direction vector. So -1, 1, -2. So that's line 1's vector, line 2's vector. And line 3's vector is 2, -1, and 3. So in order to find the angle between them, to find the angle between these, the cosine of theta equals the dot product of my vectors divided by the length multiplied of each of my vectors. And I'm going to find the angle between these two lines, which means I'm going to want to find the acute angle, which means I'm going to take the absolute value of my numerator. So going through my work, when I take the dot product, the cosine of theta, therefore equals -1 times 2, so -2, plus 1 times -1, -1, plus -2 times 3, which is -6. Again, I'm going to take the absolute value of that, divided by the length. The length of vector u is 1 squared plus 1 squared plus 2 squared, which is 6, times the length of vector v. So the square root of 4 plus 1 plus 9 is 14. So the cosine of theta equals a positive 9. It was -9. Take the absolute value over the square root of 84. Inverse cosine both sides. Theta equals 10.9 degrees. If I wouldn't have taken the absolute value of my numerator, I would have ended up getting a -9, cosine inverse that, and then I'm going to end up with 169.1 degrees, and then subtract that, of course, from 180 to get the supplement to it. Just taking the absolute value of it already takes that into consideration. So I showed that lines 2 and 3 intersected, and I found the angle between them. If I really wanted to find the coordinate point where they intersected at, again, plug in 1 for u, plug in -2 for t, and you'll end up getting the point for where they intersect. And then the second part to this example wanted to show that lines 1 and 3 are skew. So if I'm looking at lines 1 and 3, I'm just going to delete this one for the time being. So I want to show that these two lines are skew. So same type of thing as before, x equals this, set the two equal. So -1 plus 2s has to equal 1 plus 2u. And then the other one, I'll start with my y value. 1 minus 2s has to equal negative 1 minus u. Solving these two. Probably do elimination with the two of them, so I'll get all my s's and u's on the same side because none of them solve for one of the single variables. So 2s minus 2u equals 2, and negative 2s plus u equals negative 2. Bringing these together, doing elimination, 2s minus 2u equals 2, and negative 2s plus u equals negative 2. Based on how they're set up, my s's are automatically going to cancel. So when I add my u's, I end up with negative u equals 0. So u therefore equals 0. Take that value, plug it back in to solve for s. Doesn't matter which one you plug it back into. Maybe I'll do this equation here. So the opposite of 2 times s plus 0, of course, equals negative 2. S therefore equals 1. So I have my u value and I have my s value. So now I can set up my third equation with my z's. So 1 plus 4s has to equal 4 plus 3u. And I'm going to substitute in the two values that I already found. I found that s is 1. So 1 plus 4 times 1 would have to equal 4 plus 0. So 5 does not equal 4. So this is my check to see if this is a true statement. Because this is not a true statement, there is no simultaneous solution to all three. Therefore, skew. So this is how you can check to see if we have intersecting lines, parallel lines, skew lines, or coincident lines.